Hello dear friends, and welcome to this our session today. In today's video, we are going to be looking at a proof, one of those important proofs in mathematics, that is to prove that the derivative of sin x is equal to cos x. And please guys, if you're new to this our channel and our Facebook page, please just hit the subscribe button and follow our Facebook page, because if you don't do that, you'll be unable to see all our contents that we have. So guys, I highly encourage all of you to hit the subscribe button and follow our Facebook page for more. And please guys, give this video a like, please, because that does motivate me to create more content. Just press the like button guys, it will not do any harm, but please just press the like button so that it's going to help others to locate our content. So let's dive straight into it guys. Just keep in mind that if you have y to be given as f of x, then the derivative of y with respect to x, dy by dx, is defined as the limit as h goes to 0 of f of x plus h minus f of x, all that on h. Great, so this is how the limit is defined from first principle. So we are going to use this same idea now to be able to show that if y equals sine x, then the derivative of y with respect to x is the same as cosine of x. Good. So this is going to give us our dy by the x now is going to be equal to what? It's going to be equal to the limit. You're going to have the limit as h goes to 0 of f of x plus h is just going to be sine of x plus h minus f of x, which is our sine x, minus sine of x, all that on h. Good. So this is how the limit is defined as. So this is now going to be, we are now going to have this guy as now the limit as h goes to 0 of, we'll expand sine h. If we do so, we are simply going to have sine of x cosine of h plus sine of h cosine of x. Good. Then minus this sine x now, minus this sine of x, all this guy now on h. So this is now going to give us, I'm going to factor out is sine x here and is sine x here. So I'm going to have the limit as h goes to 0. Now if I factor out the sine x now, I am simply just going to have, here is going to be sine of x into, if I factor out sine x here, I'm going to have cosine of h. I'm going to have cosine of h minus 1, all this on h, that's I'm factoring out and I'm splitting, plus sine of h all over h, then cosine of x. Good. So this is what I have, and now I'm going to split this guy now into two limits. So I'll just write here as I have my dy by dx to be the same as the limit as h goes to 0 of sine of x, then into, I'll put my bracket, I have cosine of h minus 1, close it, all that on h, then now plus the limit as h goes to 0 of now sine of h, all that on h, times the cosine of x. I know that this limit, that's sine h over h, this is going to give me 1. Good. So this guy simply gives me 1. Then now I know that this, in this case now, I'll simply have this my limit to give me 0. Good. Because when cos h becomes so small, this cos h is just the same like 1 minus h squared on 2. Then this minus 1 will simply cancel, then h reduces. When you plug in 0, you simply have 0 times sine x, which gives you 0. So in the end result now, we simply have, in this case now, we are going to have our 1 times cos x, which just gives us cosine of x. Good. So the limit of this guy gives us cos x. So this is, that therefore implies our dy by dx. That therefore implies now our dy by dx now. dy by dx now is the same like what? Cosine of x. Yay. So this is the proof. Good. So guys, please subscribe to my channel for more tutorials, and you can only watch the next proof if and only if you're a subscriber. Thank you for subscribing. Thank you for following my Facebook page. The link to that page will be in the description for your convenience. Thank you.